Good. Powers consist of an exponent and a base. So I'm going to write an example. 2 to the power of 4. Which part of this power is the base? Good. This is the base. And what is this part of the power referred to as? Good. What do they tell you? What do the base and exponent tell you? The exponent tells you how many times you are going to multiply the base by itself. So a power is, as we just read, repeated multiplication, right? You guys should be taking notes here. It's repeated multiplication. The base tells you how many, tells you what number is being repeatedly multiplied. And the exponent tells you how many times to multiply it. So 2 to the power of 4, how would I represent that as repeated multiplication in expanded form? Good. I'm writing the base 4 times. 1, 2, 3, 4. I can also write it like this. Okay? Remember we talked about if you have brackets, that also means multiplication. Now, when we get into examples that have a negative base, it's better to write it with brackets. So I'll show you an example. What do you notice about this example? Yes, because the base now is negative. So I'd write negative 2 times negative 2 times negative 2 times negative 2. I want you to try these next 3 examples on your own. I want you to try 2 to the power of 3 and negative 2 to the power of 3. I want you to write it as repeated multiplication, and then I want you to evaluate it. So we have 2 times 2 times 2, which is equal to 8. Good. Now, that's equal to a positive 8, correct? Let's look at the next one. We have negative 2 times negative 2 times negative 2. Raise your hand if that's what you got for the second example. When you evaluate this, what's negative 2 times negative 2? What's negative and a negative times a negative? Positive what? Good. If I have positive 4 multiplied by negative 2, now we have a positive and a negative. Positive times a negative? Negative 8. Do you notice the difference here? Here the base was positive and it was to the power of 3. Here the base was negative and it was to the power of 3, and we got a negative result. We're going to talk about that a little later on. 2 to the power of 6. Instead of writing out, punching in your calculator 2 times 2 times 2 times 2 over and over, does anyone know the symbol for using your calculator? What do you punch in first? The base, so 2. And what's the symbol for to the power of? Okay, now some calculators are different. On yours, does it look like this? Does anyone have a calculator that looks like this? Does anyone have a calculator that looks like this? These are all the buttons that you can use to the power of. Then we would punch in 6 in this example, equals, and what's the answer? What's 2 to the power of 6 equal to? 64. What's 3 to the power of 4 equal to when you evaluate it? Yes? 81. Good. What's 3 to the power of 5? It's right on your paper, 243. And what's 3 to the power of 6? 729. What happens, what do you notice is happening with these numbers? Are they increasing or decreasing? They're increasing, right? They're increasing a lot. They grow very quickly. Do you think that happens with fractions and decimals? Well, let's see. I want you to evaluate 0.5 to the power of 2, 0.5 to the power of 3, and 0.5 to the power of 4. I want everyone to evaluate these 3 examples. When we evaluate powers that do not have a whole number as the base, what happens? What happens to the solution? The number decreases, right? 0.25 is greater than 0.125 and 0.0625. Notice the numbers are decreasing because the base is not a whole number. So what do you think? 1 to the power of 100 is equal to what? 1. The base is 1. I'm repeating 1 times 1 times 1 100 times. What's 0.5 to the power of 5? 0.03125. Which number is greater? 1 is greater than this. Right? Don't get fooled by the exponent. Just because the exponent's higher doesn't mean the number's greater. It depends on the base.
Made with Doodlecast Pro.